Hey there, welcome back to another video with the Math Doc. We are continuing with linear equations. If you're new to the channel, please check out the previous linear equation videos. Please subscribe. Today we will discuss specifically linear equations with absolute values. And in a previous video, I introduced absolute values. We kind of discussed what they mean. But I will remind you a little bit of what the absolute value is so that we can deal with the linear equations right after that. So as a reminder, the absolute value of a number is the distance between that number and 0, right? So it's the distance between A here and 0. And let's look quickly at a number line. If this is 0 and A is a positive number, this distance here is just the absolute value of A. But if we look at negative A, the distance between negative A and 0 is exactly the same, and so the absolute value of negative A is equal to the absolute value of positive A, and they're both larger or equal to 0. So an absolute value is always a positive number. It can be 0. If we're looking at the absolute value of 0, the distance between 0 and itself is just 0. But otherwise, for every other real number, it is a positive number. So it has a positive value. And that's really the most important property when we're starting to think about linear equations with absolute values. There will be other properties we use, and I'll remind you of them as we go along, but this is really the main property. And so when we talk about linear equations with absolute values, what are we thinking about? Well, let's look at a very simple example. What about the absolute value of x equals 5? This is an equation, right? We have the equality here, and it's a linear equation because we have our variable x, and it's has only one power of x. So basically, this is a linear equation with an absolute value term. What is the solution for this? Well, if we look at the number line again, obviously 5 and negative 5 are both solutions of this equation because the distance between positive 5 and the distance between negative 5 and 0 are both equal to 5. So this is a trivial example, a very simple one, but it highlights something really, really important, and that is that this equation has two solutions, okay? Until now, all our linear equations had one single solution, and that is typical for a linear equation that you will have one solution. But in this case, because of the absolute value and because it has this symmetry around 0, we actually get two solutions. And that's really one of the most important things you should remember about linear equations with absolute values. Let's go on and look at a slightly more complicated example here. And this example will help us understand how we can try and actually solve any equation, any linear equation with absolute values. So let's look at the equation. Absolute value of x minus 2 equals 2. Okay, so now again we have the mixed term here of variable and constant within the absolute value brackets, and we have to remember that we're looking at a situation where we have an absolute value of some kind of term here, right? And that term can either be positive or negative, and that will lead to the possibility of two solutions for this equations. Before we go on and actually solve, let's set up the number line again and look at what we have here. So 0, 1, 2, 3, 4, 5, and negative 1, -2, -3, -4, -5. So this is the x-axis, right? These are x's. Let's look sort of below this at an axis of x minus 2 absolute value. So let's see what values this takes. So let's start here at the top at +5, or we're looking at the absolute value of 5 minus 2, right? We've just substituted 5 inside this term x minus 2. So 5 minus 2 is 3, and the absolute value of 3 is 3. Here we have 4 minus 2, and the absolute value of 4 minus 2 is the absolute value of 2 is just 2. One more here, we have 3 minus 2, absolute value, that's the absolute value of +1, which is just 1, and 2 minus 2, 2 minus 2, absolute value is 0. Right? We have the absolute value of 0. Now we get to the interesting ones. 1 minus 2. 1 minus 2 is just -1. The absolute value of -1, I'm going to write that here small, is +1, right? Because we're looking at the distance between -1 and 0, and that's just 1. What about 0 minus 2? The absolute value of 0 minus 2 is the absolute value of -2, which is +2 again, and I'll highlight that with a positive. Let's do another one or two. -1 minus 2. -1 minus 2 is -3, so the absolute value of that is just +3. And then let's do this last one, -2 minus 2. Again, we're substituting the number in the place of the x, the variable. We get the absolute value of -4 or -4, which is just +4. So here we have the values, okay, right down here, this is the value of the absolute value of x minus 2 for each one of these. Now we are looking for the solutions for this equation, for x minus 2 equals 2. Now we did find two of these here, right here, 2 and +2. This one is for x equals 4, and this one is for x equals 0. And so x equals 0 and x equals 4 are solutions, right? So we did this just by looking at the number line and going from one number to the other and checking and solving. And so we were able to find two numbers that solved this equation, and those were x equals 0 and x equals 4. And so that's one way of solving this, just looking at the number line and going along it and finding the solutions. Now obviously that works well for an equation like this, where we're looking at these low numbers, -2 and 2. But working with the number line, if we have large numbers or we have a more complicated equation, is not as simple. So we need a more arithmetic way of looking at this. So let's write out this equation again and see if we have a slightly simpler way or a more general way of solving this. So when we look at the absolute value of x minus 2, we know that we actually have two cases here, right? And that's what leads to the two solutions. We have two cases. We have the case where inside the absolute value is a positive term. But we also have the case where inside the absolute value is a negative term. And we know that for each one of these, the absolute value basically is a different function. For the positive term, right, the absolute value is basically just like a regular parentheses. But when we have a negative term inside, things are more complicated. When we have a negative term inside the absolute value, we have to take the positive value, and the positive value is just negative or minus the value of the actual term. So for instance, if we had inside the absolute value -4, we know the absolute value of -4 is just 4. But that would mean, right, that when we take this function, the absolute value here, we're basically switching the sign. So we're taking the negatives of what's inside. So when we have x minus 2 here, we can have two cases. We can have x minus 2 is just a positive, and then so the absolute value equals x minus 2, and that equals 2. But if x minus 2 is a negative number, when we take the brackets off, we have to say that x minus 2 equals -2, right? Because this is a negative number. This negative number, its absolute value equals positive 2. So the actual number is negative. It will equal -2. So in this case, we have a different equation. We basically have two different equations for the same equation of absolute value x minus 2 equals 2. Let's repeat this again. We have inside, let's just write this out again and just repeat it for the sake of understanding it a little better. Our equation is absolute value of x minus 2 equals 2. Okay, now we have two cases. We have the case where what's inside the absolute value is positive, okay? So we're saying that x minus 2 is greater than 0. In this case, the absolute value of x minus 2 equals x minus 2. So in this case, we can just write x minus 2 equals 2 because it is positive. X minus 2 is greater than 0. What if x minus 2 is less than 0? In that case, the absolute value of x minus 2 equals 2, but because x minus 2 is actually a negative number, it should equal the negative of that value. So it equals -2. Okay, so we have these two cases. Now we have two solutions. We have x minus 2 equals 2, and we have x minus 2 equals -2. And each one of these will give us a different solution. So let's solve. So here we'll use the addition property. We'll add 2 to both sides of the equation here on the right, on the left. So we have x -2 plus 2. That is just 0. We have x equals, and here we have -2 plus 2, so that is 0. So one solution is just x equals 0. What do we have here? Here we're also going to add 2 to both sides. We'll use the same property of addition. We have x plus 0, right? Because -2 and +2 cancel. And we have 2 plus 2, that's just 4. So we get x equals 4 here. So overall, we have two solutions. We have x equals 0 and x equals 4. And those were the exact same solutions we found when we were looking at the number line right here. Right? We found x equals 0 and x equals 4, just as we did over here. Let's look at one more example, just for practice. Let's look at a simpler example. For instance, x minus 1, absolute value, equals 3. Okay. Now, again, let's solve this in the same way, in the two ways we solved previously. We'll start a number line. Here's 0, 1, 2, 3, 4, 5, and -1, -2, -3, -4. So here we have our x-axis, and let's change color here. Here we're going to look at x minus 1, the absolute value. Again, we'll start at 5. So we have the absolute value of 5 minus 1, which is equal to 4, to +4. We then have, for 4, we have the absolute value of 4 minus 1, which is the absolute value of 3, so that is positive 3. 3, 3 minus 1 in absolute value, that's the absolute value of 2. 2 minus 1 is just the absolute value of 1. 1 minus 1 is the absolute value of 0. Now we have 0 minus 1. We have the absolute value of negative 1, which is positive 1. The absolute value of minus 1, negative 1, minus 1, right? So that's negative 2, which is and the absolute value is positive 2. And we have negative 2 minus 1. The absolute value of that is the absolute value of negative 3, which is positive 3. One more, negative 3 minus 1 is the absolute value of negative 4 is just positive 4. So again, what we've done is for every x, we've substituted into our equation here in order to find the value of the term in the absolute value. And again, we can see that we have two results, two solutions that are correct. So we're looking at solutions that show that x minus 1 absolute value equals positive 3, and that is for negative 2 and for 4. So x equals negative 2 and 4. These are our solutions. Now, let's solve using our other method. Let's look at the equation again. We have absolute value of x minus 1 equals 3. And now we look at two cases, right? We look at the case where the x minus 1 is less than 0, and we look at the case where x minus 1 is larger than 0. So the easier case is when x minus 1 is positive. When that's correct, then the absolute value is actually just equal to the term itself, so x minus 1 equals 3. On the other hand, when we have x minus 1 is less than 0, what's inside the absolute value should be negative, so it equals negative 3. And we can go on now and solve. So again, we'll use our addition property for both sides. So we have x on the left-hand side because negative 1 and 1 cancel, and we have negative 3 plus 1, which is just negative 2. So our result is x equals negative 2. Here again, we'll use the addition property. We'll add 1 to both sides, and we get x on the left-hand side because minus 1 and 1 cancel, and on the right-hand side we have 4, so x equals 4. So again, we got the same results, that x equals negative 2 and 4. So these were simple results. We still have to look at slightly more complicated examples, but we kind of went through the gist of what we're looking for. We're usually looking for two solutions, and we find these by remembering that we have to look at a positive and negative term inside the absolute value. Let's look at one more example before we go on and end this video. One more simple example, which again highlights the basics of how we solve these equations. And in this case, let's look at a simple equation. The absolute value of 5 times x equals 20. Okay, and the property here is that we have a coefficient. So this is actually even simpler than the previous examples, but it's worth looking at just to remind ourselves about other properties of the absolute value. So in this case, we're looking at 5 times x equals 20. And again, we can look at the two options here that we have, that 5 times x is positive, in which case 5 times x equals 20, simply. And the case where 5 times x is negative, in which case 5 times x equals minus 20, right? Now in both cases, we can use the division property. I'm going to do them in parallel here, so we can divide by 5. And we get, in this first case, x equals minus 4, negative 4. And in this case, x equals 4. Okay, so that is the solution. But that is really a little bit too simple. The point is that when we look at this equation, we can do something prior to looking at the term inside. So we have 5 times x in absolute value equals 20. Now, it's important to remember that when we have the absolute value of a product, that equals the product of the absolute values. So if we have the absolute value of A times B, that equals the absolute value of A times the absolute value of B. In this case, then, we can write this as absolute value of 5 times absolute value of x equals 20. This really simplifies our work because the absolute value of 5 is just 5, right? So we have 5 times absolute value of x equals 20. And now we can divide by 5, right, using the division property. So we get the absolute value of x equals 4. And the absolute value of x equals a number. We know how to solve this. That means that x equals either negative 4 or positive 4. So it's a simple solution. So I just wanted to review this type of example as well, so that you had an idea that when you have a product inside without additional addition, you can just take the coefficient, this constant, out of the absolute value brackets to make it a simpler equation. So this is the end of this video. We will have another video dealing with slightly more complicated problems, specifically word problems with absolute value, and we will also look at equations where there's more than one term in an absolute value, which again complicates things a little bit more. So thank you again for joining me for another video. If you haven't subscribed, please do. Please like, please comment. I'll be happy to answer any questions in the comments, and see you in our next video.